So here's service object types, cluster IP, node port to load balancer. So how these components working? So port to port communication via service discovery endpoints. We discussed. Now label selectors. So this label selector means the service have selector keyword called. So in that selection, in that selector, we have to mention pod label. Then only this pod will communicate with other pod via service. So here label selectors. Services uses label selector determine which pods they should route traffic to. When you create a service, so here when we create service, you specify a set of labels that pod must have in order to be included. So in the service section, what are the selectors? In the selector section, what are the labels you have mentioned? Same labels you need to provide, include this pod level also, pod label section. Then only multiple replicas. So not multiple. So this pod will get external access. If you need, if you use those node port and load balancer. So those objects who can access these services. Next component, next object, service and config map. Config map are in the pod, we have to mention environment variables. So if you want to define any environment variables, you can use env. In the pod definition file, there is a keyword called env. So in that section, you need to mention name and value. So these are the key value pairs. This config map maintained configuration data in the form of key value pairs. So if you need this type of where we need these environment variables, if you want to create any database related pods, so those kind of pods definitely we need to pass environment variables. So if you pass in the definition file itself, environment variables mean that is a static configuration. One pod is created, we can't change. That is only assigned assigned to the pod directly in the static way. So config map is used environment variables dynamically. Means if you want to update any configuration data in the config map, all updated data is dynamically assigned to running pods. So that is take care about config map. So if you want to any update configuration data, means previously you have used some username and password for database. So if you want to update in future any other name, so those updates are dynamically assigned to the specific pod. This is about config map. And practically we'll discuss and statically defining environment variables, directly in the pod level, and how to use these configuration data dynamically by using config map. So next, namespace. In the cluster, if you create any namespace, that namespace assigned to specific project. So that project related to that Kubernetes, and Kubernetes cluster understand that this project is related to this specific namespace. So we have Kubernetes cluster. Inside the cluster, we have created namespace 1, namespace 2, namespace 3. So in this case, namespace 1 is for one project and namespace 2 is for another project. Namespace 3 is for third project, like that. So teams also Kubernetes. So each project have multiple teams. Each and every component access rights, those candidates accessing these resources and namespaces. So by where it came into the picture means Kubernetes RBAC. So role-based access control. In that case, you will understand clear picture about these things. Replication controller. So replication controller. So replication controller maintains desired pod count. So how will means cluster. Replication controller. So inside this is the high level component for pods, all running pods. So inside the replication controller, we have multiple copies of the same service. So pod 1.
ఎందుకు ఎక్కువ తలంతా కావాలి
So pod
సాగు ఒకరో పెట్టుకుంటారు ఇంటికి
hello Madhuri, mute. So this replication controller has a high level component for these all pods. So here pod 1, pod 2, pod 3, pod 4, pod 5. This is the desired count 6 by 6. So self-healing mechanism. So there is a section called you need to define in the definition file. Select a application section. You need to mention this count. So this is when mention this count also we are assigning statically. So when this auto scaling feature one came into the picture, so horizontal pod auto scaler when discussing it, you will understand auto scaling features. So replication controller provides only load balancing. So understand. So here 6 pods are running. So some issue, this pod is crashed. So immediately background this replication controller creates one more pod. So in this node are some hardware where hardware resources available, that particular node immediately it is recreating because Kubernetes have self-healing mechanism. So this replication controller have self-healing features. So always it should focus on this desert count on maintaining or not, these pods are running or not, what are the count we are giving. So clearly monitoring this replication controller. So this replication is controller is now deprecated. So replica set. So currently same features providing replica set and also supports replica set provides rolling updates. So replication replica set controller only maintaining desert count. Replica set can also do desert managing desert count and also rolling updates. So additional features added this replica set. Next step, resource deployment. Auto scaling and rolling updates. So here very compulsory we are asking what is the difference between deployment and replica set and replication controller or deployment and daemon set and deployment and stateful set. So mainly deployments used for stateless applications. So this is the cluster. These are the pods. So deployment is the high level component for these all pods, right? So when you deploy, deployment automatically replicas it created. So that will take care about the Kubernetes. This deployment will create stateful set dynamically. We don't want to create actionally. So replica set means already you know it is maintaining desired count. If anything pod crashes immediately, it will recreate. So but here deployment, it's a when you assign 6 pods in the replica section, so it will create 6 pods, but it is creating randomly in the cluster. So which nodes are available means which node is ready to give resources for pods. Immediately that particular pod assigned to that particular node. So some node is not ready to give the resources to the pod. So that node is waiting state. So other node, these pods are created and rolling updates. So coming to rolling updates means if you pod running on one specific version. So if you need to, if you want to update that specific version to another version, so means so some services running on previous version called some version 1.3. So new version for 1.4. So if you update this kind of updates, this kind of patches, this deployment will support. This feature also added. So mainly deployments used for stateless applications means Java. If it is a Java based applications means already you know web application means we have 3 layers. One is web, another one is web. So other one app layer. Next to DB. So every application has 3 layers. So one is web, one is a app, another one is DB. So here web and DB maintaining some required information. These kind of things you need to use stateful sets. Only app means so here HTTP request getting this web from this APIs, this app server. So app server means Java kind of applications or .NET. So these kind of all applications can be called as stateless applications. These stateless applications only. So getting request from HTTP request, receiving the HTTP request and send to DB and fetching the live data. So here app app services means stateless applications is not maintaining any data. It is getting the request and for sending the specific that request related data only. So it is a mediator like API. So in that case, in the cluster, any pod crashes deployment. In the pod crashes, immediately it will recreate new ID, right? Every pod has new IP generated. So in that case, we are not losing any data because stateless applications not maintaining any data. But deploy but stateful set we need to store this DB related data. So definitely here understand if even pod crashes, we need to persistent that data. So that so in this case, stateless applications is the best use case for deploying up stateless applications. The deployment is the best feature. resource. So now stateful sets. Coming to stateful set. In the cluster. Here completely depending on stateful applications only. When you talk about persistent, we need to take backup data. In that case, always talk about stateful sets. I'm creating multiple pods means the load balance. You need to handle the load. That's why we are using multiple pods for same copy. This is the MySQL database pod. For same service, these all are copies. Means it is load access. It is when getting the huge load, it will share across the all pods. So that is about load balancing. So here also auto scaling features supporting. So when pod crashes immediately, it will newly created pod, but stateful set is maintaining desired IP. See here. This is the MySQL. When you talk about deployment, randomly created all pods. So means randomly generated IDs. But stateful set not like that. It is maintaining MySQL 01. So 0, 1, 2, 3, 4, and so on. Here given desired count is a replicas 8. That's why. So it is maintaining like that. If this body crashes immediately, it will recreate it with same ID 0. So like that, it is maintaining desired count. That's why we are not losing any data. Same IP will assign to same pod. So here also additional capability we are going to mount this volume specific external volumes EPS and EFS. So that is a great feature about stateful sets. But deployments also having, if you want to mount locally in the cluster node level, you can. But if anything node crashes immediately, entire data going to loss. So in that case, definitely we'll go for external volume mounting. So these are the great advantage of Kubernetes. So clear today these topics you can understand. So here rolling updates also supporting load balancing, auto scaling, load and rolling updates. Portability, these all high availability, these all features stateful and deployment set providing. Load high availability. Today topics are over. So there are how many components completed, odd and service, 3, 4 namespaces, 4, 5, 6, 7, 8. So read completely. I will share the document today. What are the things explained? I will share text contents also. You need to read because you need to explain enter clearly. That's why I'm sharing. Otherwise, only I'm sharing this screen only. These pictures. So ఇక్కడ మీకు ఏమన్నా డౌట్స్ ఉంటే